Hi there, I want to introduce you to my new open source Solidity legal contracts GitHub repo. And I'm hoping that when you see this, you might be motivated to at least check it out, and even more so, possibly to add some contributions. The idea here is that I believe strongly in the smart contract mechanisms and the automated way that they can change the relationships among parties to the smart contract. What I'm trying to do is take that and bridge it with the traditional legal system. So I'm going to give you a very quick overview here, maybe just take a couple minutes on this slide share or on this screen share, and then we can dive into more issues later. This is the overall structure of the project, which you can get on GitHub. I'll show you how in just a second. You can see that the project was set up using the Truffle suite, which you should absolutely have installed if you're doing any Solidity smart contract development. The README has some information that you can read on GitHub. I'll show you in a second. You can see here that it's structured with a contracts folder and a test folder. The first example I built was called a bill of sale. I wrote this up on Medium yesterday, but a bill of sale is basically a document that basically captures the terms that parties will use when they buy or sell a good usually. So if you go buy a crypto heater, you might say to somebody, you'll show up in person and say, I'll give you $10 for, or I guess in this case more like somewhere between 4 to 5 ETH for a crypto heater. And the guy that has the crypto heater, the person says, sure. And you guys trade hands. You hand over the ether somehow, right? Maybe with your wallet. Maybe you use just cash, and the seller will give you the crypto heater. And then you might sign a document that describes the terms just for documentation purposes. The problem becomes a little more complex if somebody, say, advertises the crypto heater on Craigslist and wants to pick it up, and a buyer says, I'll buy it, but I want to pick it up this weekend. Now you've got kind of a trust problem, right? Because the seller is going to hold on to that item and tell other buyers that he will not sell it to them, and he or she, as a seller or buyer, will show up on the weekend hoping that the item is still there, or that the seller still has it available. So the bill of sale example here I have has this kind of escrow notion. I built it using test-driven development. I apologize for all the gratuitous license terms. I'm a lawyer. I have to do that. And these are the test cases. So let's walk through these first so we can understand what the technology is doing. First, and by the way, I am not a super seasoned developer of Solidity. I have a lot of software engineering experience, but like a lot of us, I'm new to Solidity too. So if you see anything in here that's a good idea, then I think that's a great contribution opportunity. So what the first set of tests are kind of mechanical. It looks to make sure that the contract gets deployed locally using the Truffle suite, which we'll explain in a second. And then you can see that at the time of deployment of the contract, it's going to have a contract owner, a seller. Here, I'll highlight these: contract owner, seller, buyer, and then additional terms, which we'll definitely talk about in a second. And then you can see these cases. It says it does not let someone other than a seller define the sale price, so only the seller can define the sales price. It does allow the seller to do it. And only the seller can define the item that he or she is selling, which makes sense. The buyer cannot do it. It also allows the seller to define the delivery method. So in this case, we're going to do FedEx. If somebody else tries to change the delivery method, it will fail. We'll walk through how all this code works in a second. It's pretty cool. Solidity is really good for this, I've learned. And then from there, excuse me, once we've agreed to the item and the price and the delivery method, then each of the parties actually has to assent to the contract. This is an important step that I think gets missed a lot in contracts for future performance in the smart contract world. Here, by saying that each the seller and the buyer are manifesting their assent to the contract, it's basically like signing it. It's basically saying, I promise to give you the ETH for the item, and seller promises to sell. Once both these things have happened, this is a super important legal moment where I think we've found a legally binding contract. It has some more mechanics here to make sure only the buyer can assent. And a next step is we move into the performance phase of the contract. So only the buyer can declare that he or she received the property, and it can't happen until everybody's assented to the contract. And only the seller, okay, sorry, I'm getting a little ahead of myself. So here's where the buyer can declare the property was received. So you can see the sale price is set, the assent for the seller is set, the buyer's assent, the buyer has confirmed receipt, and that should all evaluate to true, or pass the test, I should say. And then the buyer has received the property, but then only the seller can withdraw the amount. And what's important here is at the time that the buyer actually funds the contract, it has to be the exact right amount. Because of the logic of the smart contract, if the correct amount isn't in there, the funds could get trapped in the contract, which we've seen that kind of problem all over in smart contract development. I'd be curious to see what you think about how robustly I've done it, or if it could be better. Anybody can actually pay for the contract, not just the buyer, which I figure, some people need their mom to pay for it. I still need my mom to pay for things from time to time. And then finally, there's a test to make sure that the contract has full performance. And then the seller can withdraw the funds. So let's look a little bit at the bill of sale Solidity contract itself. You can see here at the constructor, we define the owner of the contract, which I thought could be different from the actual buyer and seller. But in reality, in the test cases, the seller and the contract owner were the same person. There's an event that gets fired when the transaction is fully performed. I haven't built a test for that yet because I'm not clear how to do it. Here you can see there's a sale price set, personal property set, delivery method, and you can see I've added modifiers, which we'll talk about, to these functions that actually limit which party can call these functions. Finally, we have a function for the seller to assent, for the buyer to assent, for the buyer to confirm the property received. We see some new modifiers here: performance reviewed, and preventing incomplete assent before calling the function. This is the function that the buyer can use to, or whoever can use to fund the contract. And this is the method, or the function, for the seller to withdraw the funds. You can see here there's a modifier for seller only, buyer, seller only, and buyer only. These modifiers are pretty cool. They're kind of like aspects you might see in Java. They're a way of adding cross-cutting concerns to the function, and you can see the little underscore here to fill in the body of the function. I'm still learning how to work this, but I think that this is a pretty cool use case for it, and I think I've done it right here. Performance reviewed, this is where this method gets called during performance functions to find out if the property received and the balance matches the sale price. This is why only allowing the funding to be exactly right is at the exact amount is here. And then we indicate that the contract has been fully performed, and we emit this event. So that's really it. It's kind of simple. Now let's roll into, you can see here there's an additional term, string. I know the string is not the most efficient way to store these, so I'd be curious for your contributions to make this better. What I've done is I will put the additional legal terms into IPFS, and you can actually see, if you want the hash, this is where it's actually stored right now. The current version is, this is the hash on IPFS for the additional terms. You can see here, this is an actual legal bill of sale, but it's been modified quite heavily to interact with the terms of the smart contract in a way that I think if a court or other lawyers or other parties were ever reviewing the transaction could understand the relationship between the smart contract code and these kind of traditional legal terms you might see. You can see it's written with Markdown, so it should still look pretty presentable once we run it through a Markdown converter. The first really important part here is the composition. The idea here is a contract. If you get into legal principles, a contract is not a piece of paper. A contract is a set of performances that a court will enforce. The piece of paper is evidence of that agreement. Here we're saying the evidence of the contract between the parties is not only this document, but also the smart contract that's deployed on the Ethereum blockchain. So I'll let you read through this at your liberty, but I think this is a super important point. I don't think it's necessarily necessary, but I think it clarifies the contract. Again, we define the parties, and their parties here are defined not only by just kind of their humanness, but also their addresses on the Ethereum network. And here is what explains how the parties reach an agreement. There's an interesting problem here about some dispute resolution that we'll have to talk through some other time that's worth discussing. For the fun of it, I added a no warranty term. This was by no means necessary to the contract. This is the section 5 is performance section is pretty interesting. I think it's useful again for legal readers or people reviewing the contract who aren't necessarily sophisticated with smart contracts, like say a jury, so they can understand how the performance of the contract takes place. You know, setting the seller field, setting the buyer field, all the stuff we talked about in the TDD or the unit tests. Finally, there's some additional terms. A lot of this is what normal people call boilerplate, but there's two very important terms here, 6A and 6B. 6A says, because there's two complicated pieces here, right? We have both all the Solidity code, and we also have this legal code. It's theoretical that there could be a conflict between the two, which is to say what this document says doesn't match what the Solidity bytecode, compiled bytecode does. In that case, I've said that the terms of the Solidity code control, which means that notwithstanding whatever this says, you have to follow the terms of the Solidity smart contract. That is a subject that you could debate about till the end of time, and lawyers probably will. The way I resolved it was to say the smart contract wins. Different parties will want to do something different, I'm sure. This also is interesting, 6B. Because interacting with the smart contract obviously costs gas or there are fees, this basically says, look, each party is responsible for their own costs on the Ethereum blockchain. Again, you know, different in future transactions between parties, they may disagree with this. They may want the seller to fund it. They may want the buyer to fund it. Just depends. So it's just something to think about. So anyway, there's some other interesting terms, but we can talk about those later. Let's actually see this thing run. You'll notice I have the Ganache private test chain running. So this is a super awesome tool for understanding how to do development. I've been heavily reliant on it since it came out. And what we're going to do is run those tests that we saw, so you can see them run. My computer is running Camtasia and other stuff, so it's pretty slow, and it's just a little MacBook Air, so it's a little slow. But there we go. We can see it running its tests. We got nice, pretty little check marks, and you can see I've got quite a few tests here. Probably could use even more. 25 passing. So our bill of sale is good to go. You are free to go and take it and use it in your own projects. You can see here is the GitHub repo. It's mrice, which is Michael Rice, Solidity/legal-contracts. You can see I've only right now got the bill of sale. We could definitely use more. Got a few issues out there, I think all written by me. Would love for you to take a look at them. I have only one contributor, which is really sad. I would love for more contributors. So I hope you will take a look at this, take it seriously, and consider contributing. Thanks for watching.